Hi, welcome to Venkat Varma Chemistry YouTube channel. I am Venkat Varma, your chemistry host and enthusiast. We are here to make JEE NEET preparation more easier and easy to understand videos. Join us for the easy to understand videos that cover key concept tips and tricks to ace your exams. In this session, we are complete discussion about alkyl halides and aryl halides in one short video and important concepts in exams. Let's begin our session. General methods of preparation of haloalkanes. General methods of preparation. The first one is from alkanes. The method is from alkanes. Alkanes halogenation in presence of chlorine or bromine halogenated to give haloalkanes. See, halogenation of alkane in presence of alkane halogenation in presence of chlorine in light at high temperature 520 to 670 Kelvin temperature, it gives haloalkanes. The example for the from haloalkanes, methane chlorination. See, methane chlorination in presence of chlorine light, it gives methyl chloride. It gives methyl chloride. Again chlorinated methyl chloride, again chlorinated in presence of light, it gives CH2Cl2. CH2Cl2 again chlorinated in presence of chlorine HNO, it gives CHCl3, chloroform. Chloroform again chlorinated, it gives CCl4, carbon tetrachloride. It is a carbon tetrachloride. Carbon tetrachloride. Yes. Next one. It is from alkanes. Now second from alkanes. Alkanes react with halogen acids to give haloalkanes. See, alkanes react with halogenated acid HCl to give haloalkanes. See, I am taking example alkene R CH double bond CH2 or CH double bond CH2 in presence of halogenated at HX, H plus X minus. See, the pi bond is shifted. Here getting partial positive charge, here getting partial negative charge. It forms RCHXCH3. This is a product. If I am taking one example for this, see, benzene with CH double bond, CH2, CH double bond CH2 in presence of HCl. In presence of HCl, it is a single bond. Okay. See, what happened? H plus Cl minus. See, the pi bond is shifted, so it forms CH2 CH plus CH3. It is a secondary carbocation. What is it is possible? Rearrangement is possible. This hydride is shifted to carbon carbocation. It forms CH plus CH2 CH3. This is the stabilized carbocation. That's why the product is formed in the presence of Cl. It gives CH, Cl, CH2, CH3. If it react with the hydrogen bromide in presence of peroxides, presence of peroxide, what is a product? Say this is a product. CH2, 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 Br. is a chlorinated product. It is a hydrogen bromide in presence of peroxide, chlorine in presence of H plus hydrochloric acid. Let's move on. Next from alcohols. Alcohols reaction with hydrogen halide in ZnX2. It means what? HCl in ZnCl2. HCl in ZnCl2. See, reaction with the HX ZnX2. I am taking example ROH alcohol in presence of H plus. In presence of H plus, what happened? It is protonated to form a ROH2 plus. OH2 minus means water is a easy living group. It form R plus. Carbocation is formed. If rearrangement is possible, say if rearrangement is possible, the product formed go through rearrangement. Yes, see. In presence of X minus, it forms Rx. Next, what is the reactivity? Reactivity order. See, order of alcohol. Reactivity order of alcohol. Tertiary alcohol is more greater than secondary is greater than primary alcohol. In this reaction, we can use sodium bromide in H2SO4 also used. It produced what? It produced hydrogen bromide. Let's say I am taking example. For example, see, it is alcohol in presence of HCl. ZnCl2. What happened? H plus Cl minus. So it protonated. So H plus, it forms what? See, OH2 plus. It lose water molecule. It formed what? Carbocation is formed. It is what type of carbocation? It is a secondary carbocation. How many alpha hydrogens are present? It is 3. It is 1. So it has 4 alpha hydrogen. What is possible? Rearrangement is possible. Hydride shift, it forms what? C. This is the carbocation. Tertiary carbocation. Yes, how many alpha hydrogen? It has 2. It has 3. 3 plus 3, 6. Yes. And it has 2. It has 8 alpha hydrogens. Yes. It has 8 alpha hydrogen. The product is formed in presence of more stable carbocation. In presence of Cl minus. It forms. This is a product. Let's move on. One more example. See, I'm taking one more example. See. Cyclobutane with alcohol. In presence of sodium bromide in H2SO4. Sodium bromide in H2SO4, it produced what? Hydrogen bromide. HBr is produced. So it forms C. Protonated, it is OH2 plus, losing of water. Yes, losing of water means it forms carbocation. Yes, it forms carbocation. So it is first position, second position. 1, 2 is cleavaged. So it forms C. This is the actual structure is. This is the structure. See, in presence of Br, it forms cyclopentane with bromine. This is the product. Yes. Let's move on. Next reaction with the phosphorus trihalide. Phosphorus trihalide and red phosphorus. Phosphorus trihalide with red phosphorus in X2. See, phosphorus trihalide means phosphorus trichloride, PCl3. Yes, it is X equal to chlorine or bromine. I am taking example alcohol ROH in presence of phosphorus trihalide. It gives alkyl halide and H3PO3. H3PO3. See, I am writing ROH is ROH. I am taking 3 moles of alcohol with phosphorus trihalide. See, PX, PX, PX. Remove the H3PO4. See, H1, 2, 3, H3PO3, H3PO3. What is the product? See, RX. 3 moles of RX and H3PO3. H3PO3. It is undergoes SN2 reaction mechanism. SN2 reaction mechanism. It is a reaction mechanism is SN2 reaction mechanism. Here no rearrangement is possible. No rearrangement is possible. No rearrangement is possible. Let's take one example. See, I am taking example. It is a OH in presence of phosphorus trichloride. What is the product? Very simple. Remove OH, add chlorine. There is no possibility of rearrangement. Simply remove the OH, adding the chlorine. So no rearrangement is no rearrangement. No rearrangement. Yes. So simply OH is removed and adding the chlorine. Yes. Have a look for one more example. See, OH in presence of PBr3. PBr3, red phosphorus with a Br2. What is the product? Here also simply remove the OH, adding the bromine. This is a product. This is a product. Here also no rearrangement. No rearrangement. Look for next method. Reaction with phosphorus pentachloride, PCl5. Reaction with phosphorus pentachloride. Yes. See, I am taking example ROH. ROH in presence of phosphorus pentachloride, PCl5. It gives RCl, okay, POCl3, phosphorus oxychloride and hydrogen chloride. This is the reaction. See, I am writing ROH in presence of PCl3 and Cl. So simply like this. RCl, yes, it form RCl, yes, and POCl3, it is a POCl3 plus HCl. It undergoes SN2 reaction mechanism. It is a SN2 reaction mechanism. Yes. Here also no rearrangement is possible. No rearrangement. Simply remove the OH, adding the chlorine. See, remove the OH, adding the chlorine. I am taking example. See, OH in presence of phosphorus pentachloride is simply remove the OH, adding the chlorine. This is our product, required product. So have a look for next reaction. Darjan reaction. So what is Darjan reaction? It is also preparation of alkyl chloride preparation. See, alcohol ROH in presence of thionyl chloride, SOCl2. It gives alkyl chloride and sulfur dioxide and HCl, hydrogen chloride. Sulfur dioxide is gas. Yes. See, for example, ROH, yes, and SOCl and Cl. So cleavage, write the product. Easy to write the product. RCl, SO2 plus HCl. Yes. This is the best method to preparation of alkyl chloride. It is the best method. It is the best method for preparation of alkyl chloride. Alkyl chloride. Why? Because of the byproducts are gases. So the byproducts are gases means it can easily remove. So we are requiring the pure form of alkyl chloride. Yes. Here also no rearrangement. No rearrangement. Here also no rearrangement. Yes. Here also no rearrangement. It undergoes SNI reaction mechanism. Intramolecular nucleophilic substitution reaction. SNI reaction mechanism. Yes. Let's take some example. Have a look for example. See. Alcohol in presence of thionyl chloride, SOCl2. What is the product? Very simple. Remove the OH, adding the chlorine. Yes. Remove OH and adding chlorine. Yes. See. Next I am taking one more example. In presence of thionyl chloride, SOCl2, what is the product? See. This is the product. See. If thionyl chloride in presence of pyridine is taken, the product gives opposite product, inversion product is given. If thionyl chloride, SOCl2, in presence of pyridine, then it gives inversion occurs. Yes, I am taking example. See, CH3HOH in presence of C2H5 in presence of thionyl chloride, SOCl2. What is the product? Simply OH is removed, adding the chlorine, CH3, so Cl, H and C2H5. Yes. If I am taking same reaction, CH3, CHOH, C2H5 in presence of pyridine, thionyl chloride in pyridine. Very simple. It gives inversion product. Opposite of OH, chlorine is attack. It gives inversion product. See, this is the product. CH3, C2H5, H. This is the inversion. Product. Yes, it is a SN2, like SN2. Okay, pyridine as base. It acts as base. It is what type product? It is a retention. Retention means same side attack. That is a retention product. Have a look for next reaction. Next is a halogen exchange reactions. Halogen exchange reactions are two: Finkelstein reaction and Schwarz reaction. Halogen exchange reactions are Finkelstein reaction and Schwarz reaction. See, the first one is Finkelstein reaction. In Finkelstein reaction, to prepare alkyl iodide from alkyl chlorides and alkyl bromide. See, alkyl chlorides, see, alkyl chlorides, alkyl bromides in presence of sodium iodide, dry acetone, it gives alkyl iodide and sodium chloride and sodium bromide. This is a Finkelstein reaction. Alkyl chlorides or bromides in presence of sodium iodide in dry acetone, it gives alkyl iodide. Simply the Finkelstein reaction used to preparation of alkyl iodides. Preparation of alkyl iodide. I am taking one example. See, general formula of Finkelstein reaction: Rx in presence of sodium iodide, acetone, dry acetone, it gives Ri, alkyl iodide and sodium halide. So in this reaction also no rearrangement is possible. No rearrangement. Yes. Next is a Schwarz reaction. In a halogen exchange reaction, the next one is a Schwarz reaction. Schwarz reaction. In Schwarz reaction, to preparation of alkyl fluorides. See, alkyl chlorides or bromides in presence of metal fluorides. In presence of metal fluorides to give alkyl fluorides. To give alkyl fluorides is the Schwarz reaction. See, I am taking general example Rx in presence of inorganic metal fluoride, silver fluoride, AgF, mercury fluoride, Hg2F2 or COF2 or SbF3. It gives what? RF. It gives RF and AgX. AgX. It is a alkyl fluoride. It is a alkyl fluorides. Preparation of alkyl fluorides. Yes, here also no rearrangement. No rearrangement. Here also no rearrangement. Yes, I am taking example for these reactions. For these reactions, yes, have a look for example. Have a look for example. See, I am taking. See, in presence of SbF3. SbF3. What? Simply remove the chlorine, adding the fluorine. Adding the fluorine. Yes, I am taking one more example. One more example. See. Here I am taking Br. I am taking Br, sodium iodide, in presence of dry acetone. What is a product? What is a product? It forms iodide. It forms iodide. Yes. We'll look for one more example. One more example. See, benzene with CH2Cl in presence of Br. In presence of Br, the reaction is in presence of silver fluoride. Expect the product. What is the product? Here chlorine is there, bromine is there, which is easily leaving group. So bromine, here resonance is possible. Chlorine, there is no resonance. So the bromine is not easy to remove. The chlorine is easy to remove. Simply, what is the product? So benzene with CH2FBr. This is our required product. This is our required product. Have a look for next question. Next question. See. See, have a look for this question. See, in presence of hydrogen bromide. Hydrogen bromide means the pi bond is shifted. Here partial positive charge, here partial negative charge. What happened? PH CH plus CH3. Yes, And what Br minus attacks over on positive charge. It gives PH, CH, Br, CH3. This is our required product. Have a look for next question. So benzene with CH2, CH3, NO2, electron withdrawing group in presence of bromination. What is the product? What is the product? See, have a look for this. See, it forms Br with CH3 and NO2. It is electron withdrawing group. Radical stability. It is a secondary. It is a primary. Which is more stable? Secondary is more stable. It form secondary product. Secondary product. It is a radical stabilization. So radical stability, based on radical stability to form a product. Have a look for next question. Benzene with CH2OH. So which is possible? Previously already I explained. OH is resonance possible. Here no resonance is possible. So not protonated this OH. It is H plus Cn minus. So easily protonated this OH group. So it forms what? OH2 form. See, benzene with OH and CH2 OH2 plus. This OH2 is easily removed. So to form a benzene with CH2 plus OH, and again in presence of Cl minus, it gives product benzene with CH2Cl OH. This is our required product. Have a look for next question. Cyclohexane with Br2CCl4. What is the product? It gives Br and Br, anti-addition, Br, anti-addition product, Have a look for next reaction. Allylic and benzylic substitution. Allylic substitution reactions and benzylic substitution reaction. But first of all, what is allylic group? See, CH3, CH, double bond, CH2. What is a hybridization? It is a sp2. What is a hybridization? It is a sp3. sp2 carbon with sp3 carbon is a allylic carbon. This is a allylic carbon. Allylic carbon has hydrogens. They are belongs to allylic hydrogen. See, have a look for benzylic. What is benzylic carbon? So benzene, I am writing benzene with CH3. Here also this carbon undergoes sp2. This carbon undergoes sp3 hybridization. This carbon is benzylic carbon. Benzylic carbon has hydrogen, benzylic hydrogens. So in this allylic benzylic substitutions, they are bromination and chlorination. See, first for example, chlorination. In chlorination, what is the reagent used for the chlorination? Very simple. Chlorination in presence of Cl2 and Hnu means light, or Cl2 at 500 degrees Celsius at high temperature, or TbUOCl. These reagents are used for the chlorination. All are gives what? Chlorine free radicals are gives. All these are gives what? Gives chlorine free radicals are gives. This is the chlorination. Have a look for bromination. So bromination, for the bromination, what are the reagent? Very simple. Br2 in presence of Hnu and NBS, N-bromosuccinamide. So what is the structure of N-bromosuccinamide? It is a N-bromosuccinamide. All these are produced bromine free radical. Have a look for example. See, if I am taking propene, CH3CH double bond CH2 in presence of NBS, N-bromosuccinamide. What is the property? It is has allylic carbon with hydrogen is replaced by bromine free radical. It gives CH2 CH double bond CH2 bromine attacked over here. Let's have a look for next example. See, benzene with CH3 in presence of NBS, N-bromosuccinamide, it gives, this is the product, CH2Br, CH2Br. Yes. If benzene with CH3, Cl2 at high temperature, what is the product? Very simple, it gives benzene with CH2Cl. See, sulfuryl chloride, allylic chlorination is carried out with thionyl chloride. See, I am taking example. For example, CH3, CH double bond CH2 in presence of the sulfuryl chloride, SO2 Cl2. So small amount of peroxide, traces of peroxides, it gives Cl, CH2, CH double bond CH2 plus HCl plus sulfur dioxide. Have a look for next reaction. Reaction with alcohol with a hydrogen halide. Reaction with alcohol with a hydrogen halide. See, first of all, what is the reactivity of order? Reactivity of hydrogen halide. So, what is the reactivity of hydrogen halide? Hydrogen bromide, and hydrogen chloride, and hydrogen fluoride. Which is more reactive? Hydrogen halide is more reactive. So, I am taking one example, ROH in presence of hydrogen halide, HX, it gives what? Simply OH2 means H2O, it forms RX plus H2O, H2O. Generally, tertiary alkyl halide, it undergoes SN1 reaction. Secondary means it undergoes SN1 or SN2. SN1 or SN2. The SN1 and SN2 we can discuss further. Okay, have a look for one more reaction. Unstreaker reaction or Unstreaker-Borden reaction. Unstreaker-Borden reaction. What is Unstreaker bromide? Unstreaker-Borden reaction. See, it is a preparation of alkyl bromide from silver salt. See, silver salt, its formula are C double bond O Ag in presence of Br2 in carbon tetrachloride. It gives alkyl bromide RBr plus silver iodide AgI and remove the carbon dioxide. Yes. Silver salt of carboxylate ion in presence of bromine and carbon tetrachloride, it gives alkyl bromide. See, simply remember this reaction. So COO Ag is remove and add Br. Remember, COO Ag is removed, just add the bromine. See, if reaction is carried out RC double bond O Ag in presence of iodine I2, what is the product? It gives ester or COOR. Ester is formed. See, 2 AgI and CO2. It forms what? Ester. What is the type of reaction? It is Simoni's reaction. It is a Simoni reaction. It is a Simoni reaction. Next is the chemical properties. The chemical property is nucleophilic substitution reactions. See, nucleophilic substitution reaction means the living group is substituted by nucleophile. that is a nucleophilic substitution reaction. In nucleophilic substitution reaction, SN1 and SN2, unimolecular nucleophilic substitution reaction and bimolecular nucleophilic substitution reaction. Have a look for the first one is unimolecular nucleophilic substitution reaction, SN1. SN1 means unimolecular nucleophilic substitution reaction. See, in presence of tertiary butyl bromide, see, tertiary butyl bromide, tertiary butyl bromide in presence of H2O, in presence of H2O, it gives tertiary butanol, it gives tertiary butanol, it gives tertiary butanol, and Br minus plus H plus. Yes, in SN1 reaction, the rate equal to depend on alkyl halide. It depend on only alkyl halide only, not nucleophile. So its order equal to 1. Its order equal to 1. Yes, it is depending on concentration of alkyl halides only. Yes, it undergoes two-step reaction. Though before that, it is favored for polar protic solvent. Favored for polar protic solvent. Polar protic solvents like what? H2O, SROH, OH bond. So HCOOH, CH3COOH. These are the solvents to favor for SN1. Polar protic solvent, PPS. In SN1 reaction undergoes two-step reaction. See, have a look for mechanism. See, what is a mechanism? See, if I am taking tertiary butyl bromide, the tertiary butyl bromide, see, the tertiary butyl bromide in presence of water, OH2, yes, it forms, see, carbon and bromine is cleavaged, heterolytic cleavage. It forms carbocation CH3 plus to form a carbocation. It form a carbocation. Tertiary butyl carbocation is formed. It is a slow step reaction. See, slow step or rate determining step. Slow step or rate determining step. See, we look for reaction. See, it is a heterolytic cleavage to form a carbocation. It is a step 1. Step 2, this carbocation, see, tertiary butyl carbocation in presence of OH2. It is a fast reaction. To form a CH3 OH2 plus. Yes, it undergoes CH3 OH, tertiary butanol to produce H plus. Yes, this is our required product. It gives a retention product. SN1, it gives retention product. Yes, I will look for example. See, for example, I am taking example CH3 O CH2 Br in presence of H2O. What is the product? Simply CH3O CH2 to form a what? The cleavage to form a carbocation. Yes, it forms what? OH2 plus. So CH3O CH2 and OH2 plus. It forms what? CH3 OCH, sorry, C. It gives CH3O CH2OH. This is our required product. Yes. Have a look for example. See, generally vinyl and aryl halides, vinyl chloride CH2 double bond CHCl in presence of SN1 reaction. There is no SN1 reaction. They are unreacted. It is a vinyl chloride. It is a vinyl chloride. Aryl chloride also. See, I am writing aryl chloride. Aryl chloride in presence of SN1 reaction. There is no reaction in SN1, unreactive. And I will look for this one. Braided head chlorine in presence of H2O SN1. There is no reaction. No reaction. Braided head carbon. It has braided head carbon. No SN1 reaction. See. Have a look for reactivity of reactivity. See, reactivity. What is a reactivity order? What is the reactivity order? See, tertiary alkyl halide is greater than secondary alkyl halide, and primary alkyl halide and methyl halide. The tertiary alkyl halide more favor for SN1 reaction. More favor for SN1 reaction. See. Have a look for SN2 reaction. SN2 reaction means bimolecular nucleophilic substitution reaction. In bimolecular nucleophilic substitution reaction is a concentrated substitution reaction, which is the bond breaking and bond forming at same time is known as SN2 reaction mechanism or concentrated reaction mechanism. Bond breaking, bond forming at the same time, that is a concerted reactions. Concerted reaction. The reaction between methyl bromide with acetate. I am taking example for the SN2. See, methyl bromide CH3Br in presence of acetate like C double bond O CH3. What is a product? It gives CH3O C double bond O CH3 plus Br minus. Yes, Br minus. See. Have a look for mechanism. Have a look for mechanism. Have a look for mechanism. The first one. See. Methyl bromide CH3Br, yes, with acetate CH3 C double bond O minus. Yes, here bromine is leaving group, OH minus attacks in backside of methyl group. It forms CH3 C double bond O CH3, yes, like Br minus. Br minus. See, I am writing. See, it is a nucleophile. See, the nucleophile is substituted by opposite of bromine. So, it is a cleavage, means the new bond formation between carbon new bond is formed. Yes, it is a breaking of bond to form a product CH3 C double bond O CH3. This is our required product, and Br minus. See, it is a concerted reaction. See, rate is rate is directly proportional to nucleophile and concentrated of alkyl halide. See, what is a nucleophile? Acetate. What is alkyl halide? Ethyl bromide. Ethyl bromide and nucleophile CH3O minus. Concentrated of nucleophile, concentration of the nucleophile and alkyl halide. That's why it is a SN2 reaction. See, rate equal to K into alkyl halide and nucleophile CH3Br and CH3C double bond O. See, it is favored for what favored? It is polar aprotic solvent. Polar aprotic solvent. See, polar aprotic solvents. Polar aprotic solvent. What are the polar aprotic solvents? See, like dimethyl formamide, acetone, dimethyl sulfoxide, These are the polar aprotic solvents. Favored for the polar aprotic solvents. Have a look for here also vinyl and aryl halide. Vinyl halide CH2 double bond CHCl. There is no SN2 reaction. There is no reaction. Do not undergo SN2 reaction. Vinyl halide also no reaction in SN2. I am writing rate equal to primary alkyl halide is greater stable than CH2X and R2CHX and R3CX. It is primary, that is secondary, it is tertiary. Primary is greater reactivity than secondary and tertiary for SN2 reaction. See, what is the difference between SN1 and SN2? See, I am writing SN1 and SN2. I am writing SN1 and SN2 reaction. See, for SN1, alkyl halide with nucleophile, it form RNU plus X minus. Yes, its stability is tertiary is greater than secondary is greater than primary. Yes, it the reaction go through carbocation. Yes, and reactivity of order tertiary is greater than secondary and primary. Yes, see, favor for polar protic solvents like H2O and alcohol and RCOOH, H plus donor solvents. See, next, ammonia. It gives a retention product. Yes, it gives a racemic mixture. Yes. Have a look for SN2. SN1, its rate is depending only on concentration of the alkyl halide, depending on concentration of the. That's why it is order equal to 1. See, SN2 also are alkyl halide with the nucleophile. It attacks backside of the nucleophile. What is the stability? Primary is greater than, secondary is greater than tertiary. Yes, it is a concerted reaction mechanism. SN1 undergoes 2 steps. Yes, it is a concerted. It favor for polar aprotic solvent. Polar aprotic solvents. What are the polar aprotic solvent? What are the? See, do not donate the H plus ions. They are what? DMF, dimethyl formamide, DMSO, dimethyl formamide, Yes, acetone, polar aprotic solvent. Yes, it gives inversion product. It gives inversion product. SN2 give inversion product. Its order equal to 2. It depending on concentration of the alkyl halide and nucleophile. That's why order equal to 2. I will look for some more example for the solvolysis reaction. See, solvolysis reaction. See, I'm taking example. In presence of H2O, it undergoes what reaction? SN1. Very simple. It undergoes SN1 reaction to form a OH. Yes, I'm taking this reaction is alcohol. Alcohols also undergoes what reaction? It gives C. Yes, in presence of acetic acid, CH3COOH. It gives what? OOCH3. Yes, and in presence of NH3, ammonia. What is the product? This is the product. Yes, next. One more example. Engine with a PR in presence of H2O. In presence of H2O. Yes, in presence of silver nitrate AgNO3 aqueous. It gives in presence of SbCl5 or SbF5 in aqueous medium. In aqueous medium, H2O in acetone and silver nitrate aqueous SbCl5 SbF5. It gives the product. It gives the product. Have a look for reagents and type of product and type of reaction. Let's move on. See, have a look for reagent, nucleophile, substitution product, mechanism. What is the main product? I am taking the first one is sodium hydroxide or potassium hydroxide. It gives what? OH minus. OH minus. OH minus in presence of alkyl halide it gives ROH. It is a substitution product. ROH, what type of mechanism undergoes? SN2. SN2. What is the main product? Main product is the alcohol. Main product is the alcohol. See, I am taking second one, H2O, water. It produces H2O. H2O. What is the substitution product? It gives ROH. What process? Solvolysis. Solvolysis. What is the product? It gives SN1. It is an alcohol. It gives alcohol. I will look for next reagent. Sodium alkoxide, RONA. What is RO alkoxide? RO minus. RO minus. What is the substitution product? It gives ROR. ROR. It gives what? Ether is formed. Ether is formed. What type of reaction? It is a SN2. What is the product? It is a ether. It gives a ether. It gives a ether. Yes. I am taking next reagent for sodium iodide. Sodium iodide means obviously gives I minus. It gives alkyl iodide. It gives alkyl. What is the reaction mechanism? It is SN2. It gives alkyl iodide. It gives alkyl iodides or gives alkyl iodides or gives. I will look for the next one. Ammonia. NH3. Yes. NH3, NH3. What is formed? Amine is formed. RNH2 is formed. Yes, RNH2 means it is a SN1. SN1. It forms what? It forms primary amine. It forms primary amine. Have a look for next reagent. See, have a look for next reagent. See, sixth one. Sixth one. What is the reagent? RNH2. RNH2. It forms RNH2. In presence of alkyl halide, it gives RNHR. Yes. What is the mechanism? It is a SN1. It gives what? Secondary amine or gives. It gives secondary amine. Yes. Have a look for next reagent, KCN, potassium cyanide. K plus Cn minus. Cn minus is a nucleophile. It gives RCN. It gives RCN. What is the product? SN2. It is gives cyanides. It gives cyanide. It gives cyanide. Have a look for next reagent, AgCN, silver cyanide. These are important reagent, KCN and AgCN. Here also gives Cn minus. Cn minus. See, it gives C triple bond N. C triple bond N. S and Ag. What is the product? It gives RNC. It gives RNC. Isocyanide. See, what is the reaction mechanism? It is a SN2. Isocyanates are gives. Isocyanide. It gives isocyanide. See, have a look for next one. Next one. KNO2. KNO2. It is O N double bond O minus. What is the product? RONO. See, it is a donor, so it undergoes SN2. It gives nitrile. It gives nitrile product. Have a look for next one. AgNO2. AgNO2. It gives AgNO2. AgNO2. It gives RNO2. RNO2. It undergoes SN2. Means nitroalkene. It gives nitroalkene. The next reagent is RCOOAg, silver salt of carboxylate. It gives RCOO minus. RCOO minus. It gives what? O. OOR. It gives ester. It gives ester. It gives ester. Next reagent, lithium aluminum hydride, LaH. It gives H minus. It gives H minus. It gives RH. It undergoes SN2. It gives alkane. It gives alkane. See. Next metal oxide, R minus M plus. See what R minus is formed? Carbon ion. It formed R dash and R. It undergoes SN2. It gives alkane. It gives alkane. This is the reagent, nucleophile, and the substitution product, and which mechanisms are involved. This is an important table for examination. See, have a look for. Have a look for example. Ethyl chloride. Ethyl chloride in presence of KNO2, in presence of KCN, in presence of AgCN, in presence of AgNO2. What are the product? See, KCN, potassium cyanide, it has ionic nature. Ionic nature means it gives CH3, CH2, C triple bond N. This is the product. Yes. AgCN, it is a covalent. It is a covalent. It gives CH3, CH2, NC. It gives isocyanides. It gives isocyanide. It gives what? Cyanides. It gives cyanides. So potassium cyanide is a ionic nature. Silver cyanide is a covalent nature. Next, look at for KNO2. In presence of KNO2, it gives what? CON double bond O. It has with a K plus. It gives what? CH3, CH2, O. N double bond O. This is the product. AgNO2 simply CH3CH2NO2. This is a product. This is a product. It is in the form of AgON double bond. This is the product. These are the product. I will look for next questions. I will look for question C. In presence of H2O, this reaction will goes SN1. What are the product? These are the product. OH, CH3, H, C2H5 plus, yes, HOH, CH3, C2H5. It gives racemic mixture. It gives racemic mixture. Yes. This is A, this is B. A and B are enantiomers. These are enantiomers. These are enantiomers. See, if I am taking second example, HDT, hydrogen, deuterium, tritium in presence, it connected with Br, aqueous KOH. Aqueous KOH means it gives what? See, HOH, it undergoes SN2. It undergoes SN2. It gives inversion product. It gives inversion product. It gives what? A retention product. It gives retention product, and the second one gives inversion product or Walden inversion. The name of scientist is a Walden inversion. Walden inversion. So, have a look for next elimination reactions. Elimination reaction. See. Have a look for elimination reactions. Have a look for elimination reaction. See, reaction which two atoms or groups removed from the compound are known as elimination reaction. In elimination reactions, there are E1 and E2 elimination, or E2 and E1 elimination. See, E1 and E2 eliminations are only difference on timing of bond cleavage and bond formation. See, I am writing E2 mechanism. E2 mechanism. E2 mechanism. In E2 mechanism, what E2 mechanism? It favored for strong base. Strong bases. What are the strong bases? Like alcoholic KOH. Alcoholic KOH strong bases, and C2H5O ethoxide, or NaNH2. NaNH2 or tertiary butoxide. Tertiary butoxide. These are the strong bases favored for E2 mechanism. It is a one-step mechanism. It is a one-step mechanism. E2 is a one-step mechanism. Yes. The reaction go through transition state like SN2 transition state. Yes. The example is a dehydrohalogenation. See, dehydrohalogenation. A dehydrohalogenation. Dehydrohalogenation. I am taking example. For example, CH3, CH3, CH3 in presence of OH minus, in presence of OH minus. See, OH minus or alkalic KOH. It gives what? CH3, CH2 double bond CH2 plus H2O plus Br minus. Br minus. See, Br minus. It gives what? Alkene. Rate equal to, in presence of tertiary butyl bromide and OH minus. OH minus. Yes. I will look for one more example. CH3, CH2, CH2, right. So you have a look, for example, in this bromine living group with the alpha position, the adjacent carbon is the beta position. Here two betas are present. The base abstract two protons in presence of ethoxide ion. It gives the first one. If eliminate this hydrogen, it gives 2 pentene. If the eliminate this proton, it gives 1 pentene. It gives 2 pentene and 1 pentene. So which is major? That 2 pentene is a major product and 1 pentene is a minor product. Why? Because of 2 pentene has 5 alpha hydrogens and 1 pentene is a 2 alpha hydrogen. See, more substituted product, it is a safe job product. It is a safe job product. Less substituted is it is a Hoffman. It is a Hoffman product. So here in E2 mechanism, no rearrangement is possible. No rearrangement, and it undergoes anti-elimination. It undergoes anti-elimination. Anti-elimination. Have a look for next one. Have a look for next one. Next is a E1 mechanism. Next is a E1 mechanism. Have a look for E1 mechanism. See, tertiary butyl chloride. Tertiary butyl chloride in presence of H2O. H2O. It gives what? This is the product. See, in CH3, 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 and for example, iodine or chlorine is present in presence of H2O. So it is a alpha position, it is a beta, it is a beta, it is a beta. So eliminate any one of the beta position because of the same. So it forms CH3, CH3 plus and I minus. Yes, again this carbocation in presence of H2O, abstract the proton, it gives CH3, C double bond, CH2, CH3 plus H2O. This is the even mechanism. So E1 and E2 are both are same, but the bond breaking and bond formation timing is different. Timing is different. See. See. Have a look for it. Have a look for this reaction. C3H6 in presence of NBS allylic bromination. After that, bromination in presence of peroxides. After that, Woods reaction. The A reaction with KCN, it gives D, and hydrolysis oxidation, it gives E. See, first of all, I am writing C3H6. What is the name of the product? C3H6. I am taking C3H6 alkene system. Alkene system means CH3, CH double bond CH2. It is a propene. Propene in presence of N-bromosuccinamide in presence of carbon tetrachloride. It gives what? Bromination. Allylic bromination means it gives CBr in presence of CH double bond CH2. In presence of hydrogen bromide peroxide, it gives what? It gives CH2Br, CH2Br. Yes, in presence of sodium diether means Woods reaction. Woods reaction means it undergoes intramolecular Woods reaction. It gives CH2, 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 CH2. It is a cyclopropane. It gives cyclopropane. It undergoes what? Intramolecular Woods reaction. It is a intramolecular Woods reaction. Intramolecular Woods reaction. See, it is a A product. Yes, it is a B. It is a C. Here giving the A with the KCN. KCN means potassium cyanide. Potassium cyanide. It undergoes nucleophilic substitution reaction. Nucleophilic substitution reaction means it gives what? CH2 CN in CH double bond CH2. Yes, it undergoes hydrolysis H3O place. It is a D. Hydrolysis, it gives what? Cyanide. Hydrolysis means it gives acid. It gives acid COOH CH2 CH double bond CH2. Again, it is oxidation. Oxidation, it gives what? CH2 COOH and COOH. It is malonic acid. It gives malonic acid. It gives malonic acid plus CO2 plus H2O. CO2 H2O. This is a good alkyl halide. Let's move on. Aryl halides. Aryl halides. Direct halogenation. Say direct halogenation. General methods of preparation of aryl halide. Direct halogenation in presence of, say, benzene, in presence of chlorine, Cl2, in presence of ferric chloride, it gives what? Chlorobenzene. See, it gives chlorobenzene. I am taking for example substituent. It is a chlorobenzene. So, chlorobenzene, orthochlorobenzene and a parachlorobenzene. If it is react with chlorination Cl2 in presence of HNO, it gives CH2Cl. CH2Cl. Yes. Have a look for next. From benzene diazonium salt. From benzene diazonium salt. From benzene diazonium salt. Benzene diazonium chloride. I am writing benzene diazonium chloride. See, benzene N2 plus Cl minus. In presence of cuprous chloride, CuCl, in presence of HCl, heating, it gives what? Chlorobenzene. It gives chlorobenzene. In presence of CuBr, HBr, it gives what? Chlorobenzene. It gives bromobenzene. It is a Sandmeyer reaction. It is a Sandmeyer reaction. Yes. If treated with potassium iodide, Ki, heating, it gives iodobenzene. It gives iodobenzene. It is not Sandmeyer reaction. See, if it is treated with HbF4, tetrafluoroborate, heating, it gives fluorobenzene. It gives fluorobenzene. It is a Bulge-Schumann reaction. It is a Bulge-Schumann reaction. Bulge-Schumann reaction. If it is treated with copper with HCl, it gives chlorobenzene. It gives chlorobenzene. It is a Gattermann reaction. If it is treated with copper with hydrogen bromide, it gives bromobenzene. It gives bromobenzene. It is a Gattermann reaction. It is a Gattermann reaction. It is from preparation of benzene diazonium chloride or benzene diazonium salts. See. If how can form benzene diazonium? See, from aniline, Na, NH2, benzene NH2, Na, NO2 plus HCl at 0 to 5 degrees Celsius, it gives benzene diazonium chloride. It is a aniline. The process is diazotization process. Diazotization process. Next method is the nucleophilic substitution reactions. Nucleophilic substitution reactions. In nucleophilic substitution reaction, chlorobenzene in presence of sodium hydroxide at copper 352 350 degrees Celsius and 200 atm pressure, it gives phenol. It gives phenol with the sodium chloride, copper salts. See, it is a Dow process. The name of the process is Dow process. Dow process. And chlorobenzene in presence of ammonia, NH3, in presence of 200 degrees Celsius and 50 atm pressure, in presence of copper salt, it gives aniline. It gives NH2, benzene with NH2 and ammonium chloride. And chlorobenzene with copper cyanide, CuCN, at 250 degrees Celsius in presence of pyridine, it gives cyanobenzene. See. Next, silver salt of carboxylic acid. See, C6H5COOAg with Br2CCl4. What is the product? Simply C6H5Br plus AgBr plus CO2. It is an Unstickel reaction. Yes, it is an Unstickel reaction. See. Have a look for determining whether alkyl halide react with SN1 or SN2 or E1 or E2. See, if tertiary alkyl halide in presence of strong base, it gives E2 product. See, tertiary alkyl halide means it is a CH3 tertiary butyl bromide. In presence of strong base like OH minus, alkalic OH, strong base. What is the product? It is a E2 product. CH3 double bond CH2. Yes. Have a look for next one. Second one. Tertiary alkyl halide which weak nucleophile or base. It gives SN1 and E1 product. SN1 plus E1 product. See, tertiary alkyl halide. Same tertiary alkyl halide. I am taking tertiary alkyl halide. CH3 Br, weak nucleophile like water, H2O weak nucleophile. It is a weak nucleophile. It gives what? SN1 means CH3 OH, tertiary butanol. E1 means it is CH3 C double bond CH2. It is SN1. It is the E1. Have a look for next reaction. Primary alkyl halide with strong nucleophile or base, it undergoes SN2. Primary alkyl halide, strong nucleophile or base, it gives SN2 product. See, primary alkyl halide means CH3 CH2 Br, strong base. Strong base means OH minus. It gives SN2, simply CH3 CH2 OH. It is a strong base. CH3 CH2 OH. Have a look for next example. Primary alkyl halide with strong sterically hindered base. What is the product? It gives E2 product. See, I am writing primary alkyl halide CH3 CH2 Br in presence of strong sterically hindered potassium tertiary butoxide CH3 O minus K plus potassium tertiary butoxide. It gives alkene CH2 double bond CH2. It is a E2 product. It is a strong sterically hindered base. Yes. Have a look for next example. Secondary alkyl halide with strong bases and nucleophile. Strong bases nucleophile, it gives E2 and SN2. Secondary alkyl halide. I am taking secondary alkyl halide. See, It is a secondary alkyl halide in presence of strong base OH minus strong base. It is a strong base and nucleophile. What is the product? See, what is the product? E2 product is see cyclohexene, and it is a OH, SN2 and E2 product in presence of strong bases and nucleophile. Secondary alkyl halide, it gives E2 and SN2. E2 and SN2. Have a look for next example. See, secondary alkyl halide, strong sterically basis, it gives what? E2 products. E2 product. Secondary alkyl halide. See, I am taking secondary alkyl halide with strong sterically base. Previous base, potassium tertiary butoxide, CH3 O minus K plus. It gives E2 product. Cyclohexene. It is a E2 product. Have a look for next example. Secondary alkyl halide with weak nucleophile or base. Weak nucleophile base, it gives SN1 E1. I am taking example secondary alkyl halide. It is a secondary alkyl halide with a weak nucleophile like H2O. It gives what? SN1 and E1. It is a SN1 E1. It is a cyclohexene. It is a SN1. It is a E1 product. It is a E1 product. See. Have a look for this question. Cyclopentane with Br2, it gives A. Alkalic OH, B. In presence of NBS, it gives C. In presence of A, aqueous KOH, it gives D. D with sodium with a dry ether, it gives E. C plus E, it gives F and G. What is the product? C. So I am writing cyclopentane. First of all, I am writing cyclopentane. This is cyclopentane with the Br2. Cyclopentane in presence of Br2 at 127 degrees Celsius, it gives cyclopentane with the Br. Cyclopentane with Br in presence of alkalic KOH. Alkalic KOH means it is elimination. Elimination means it gives cyclohexene. Cyclohexene in presence of NBS, N-bromosuccinamide, means allylic bromination. Allylic bromination means it gives, see, this is the product. This is the product. It is A, yes, it is B, it is C. Have a look for A with aqueous KOH. See, A with aqueous KOH. Aqueous KOH means it undergoes nucleophilic substitution reaction. The bromine is substituted by OH. Yes, yes. Next, OH in presence of sodium in dry ether. Sodium in dry ether, it gives what? Alkoxide. O Na. So it is a product is a D, it is a E. It is a E. C plus E. C plus E. So I am writing C plus E. C plus E means these two are, what is the product? It gives C plus E. It gives this is the product. It is a elimination product. It is a elimination product. This elimination product is stable conjugated system. So it is a stable conjugated system. So the next product is see, it forms is a F product, it is a G product, F product and G product. It is a substitution product. It is a substitution product. It is a substitution product. Which is major? Elimination product is a major because of it is a conjugated stabilization. It is a conjugated stabilization. Yes. See, this is our alkyl halide and aryl halide complete in one shot. See, I hope you like this video. Don't forget to share your friends. Don't forget to give like. If you find content is valuable, make sure to subscribe to our channel and hit the bell icon to stay updated with the latest updated videos and notifications. Thanks for watching.